Hi guys, welcome back to the channel. My name is Jag, and in today's class we are going to continue with our Math 11 content, and today the topic is the vertex form of a quadratic function. Okay, so you might have noticed that basically this topic was covered last year in grade 10, and just like I said before, okay, the quadratics unit is repeated in grade 11. Okay, so with that, let's get started. And I'm going to read the question out loud, and we're going to try these examples together. Alright, so the first example is, for each function, state the vertex and whether the function has a maximum or minimum value, and explain how you decided. Okay, so I'm going to pick maybe a function from here. So let's put example. Okay, so we're going to do f of x equals 2, and then x minus 3 squared minus 5. So this is actually the vertex form of the quadratic, okay? So how you know is basically there will be a value inside the bracket squared, and then there will be a value outside the bracket as well, okay? And if I'm looking for just the vertex here, okay, how you do this is whatever is inside the brackets, I'm going to change the sign. So you see how it says x minus 3? This is going to be x is positive 3, okay? And the number that's outside the bracket is actually the y point of the vertex. I have to make sure I'm not changing the sign and take the sign that's in front of this number. So it's going to be negative 5. And that's all you're doing, okay? So that's one of the reasons that I do use the concept of completing the square to change from the standard form into the vertex form, all right? And that way I know what the vertex of the parabola is right away, okay? Alright, and it says you have to state whether or not it's a maximum or a minimum value, okay? And how you do that is I'm just looking in front, outside the bracket here. You see how there isn't any negative sign in front of the 2? So that tells you that the parabola is opening upwards. So let's put the opening as well. Okay, so I'm going to put opening upwards. Okay, and we will try one more example, okay, so you can see the difference. So opening upwards just basically means that the parabola looks something like this, okay? And whenever it opens upwards like this, okay, this is actually a minimum value, okay, that the parabola has, all right? And if it was opening in the other direction this way, okay, we'll put a dot. The dot represents the vertex, okay? And if it's opening downwards, this would actually indicate that it's a maximum value. Does everyone see the difference there? Okay, so you notice in the different forms of the parabola, so this is basically the vertex form of the quadratic function, and I do have to memorize specific terms, okay, like minimum, maximum values, and that's how you can explain, okay? It can also be a communication question, explain how you decided, and that's how I would explain it, that there is no negative sign in front of the 2 here, which indicates that the parabola is opening upwards, okay? And the value that it's occurring at is basically negative 5. Okay, which is just basically the y point of the vertex, okay? We're not doing an exact sketch here, but if you were to graph out the parabola, it would basically just look something like this. Okay, and the vertex would be at 3 and negative 5. Are there any questions? Okay, let's try one more example. Okay, I want to show you one that has the negative sign in front. So I'm just going to take this off. Okay, and remember when it says f of x, okay, that just means that it's a function. Okay, so let's try this one, or this example here. So I'm going to put f of x equals negative 3, and we're doing x minus 5 squared, okay, and then minus 1. So this is my function now. Again, I'm going to write out what the vertex is. Okay. And you're just going to change the sign again, okay? So inside the brackets, it's negative 5. I'm going to change that to positive 5. Okay, and outside the brackets, I have negative 1. And this is the y point of the vertex, okay? So again, for the y point, make sure you are not changing the sign. I'm just keeping this the same, okay? Now, if you notice in front here of the 3, how there's a negative sign. So let's put the opening, okay, of this parabola is downwards, okay? And again, it's not the actual value like the 3. I'm only seeing if there's a negative sign in front, okay? And I know that it's opening down like this, okay? So is this a maximum or is it a minimum? Okay, so remember it's kind of like a hilltop, and I think of the hill as basically being a maximum. Okay, so this is going to be a maximum value at, and I'm going to just use the y point of the vertex, which is -1. Okay, so I'm just going to put at -1. Okay, and that's how you do a lot of these questions. Again, these questions are just like knowledge-based questions. Okay, but make sure you still know how to do them so you don't lose any marks on a quiz or a test or even the final exam. All right, so with that, let's move on. Let's try one last example. Okay, so this example is going to be slightly different. Okay, and what you're going to do is they give you a graph here. So it says for each graph, write the quadratic equation in vertex form. Okay, now it gives you the vertex, so I'm just going to put vertex as v here, and the vertex for this question is -3 and -4. Okay, and then it gives you the graph. Okay, and it gives you a point that is on this parabola. Okay, so again, this can also be given as like a word question. All right, it doesn't have to be as a graph. Okay, I'm going to put down the point, and the point that's given here is 0 and 5. Okay, and I am looking for the equation of this quadratic in the vertex form. Okay, so because the vertex form is given, this is the value of a. Okay, it just tells you whether or not the parabola is a vertical stretch or a vertical compression. Okay, I don't know the value for a. I'm actually always solving for this. All right, so first we're going to just take our x and y points, I guess, for the vertex. I'm going to do x. You see how the x point of the vertex is -3? I'm going to put x plus 3 squared minus 4 because that's the y point. And don't change the sign for the y point, so I just left it as -4. Then I'm going to look at this point that is given to me. Okay, I'm going to use the x and y points. All right, from this point, so I can see that the y is 5. I'm going to plug this into my equation. I'm still solving for a, so I'm going to leave that the same. And the x point is 0. So I just plugged in the value of 0 into my equation and keep everything else the same. Okay, so if you look at this equation now, I can see I'm solving for a. It is the only unknown variable here, and it always has to be like this or I can't solve the equation. Okay, there has to be one unknown value. All right, so let's do the steps here. And again, it is a simple equation. If you are really good at the equations, you can skip over some of these steps. All right, so in brackets here, this is actually 3 squared minus 4. All right, I'm going to take this -4 to the other side and make it positive. Okay, so I'm just going to write it here. On the other side is going to be 5 plus 4, which is 9, equals to 8. And I'm doing 3 squared, which is 3 times 3, which is also 9. Okay, I'm going to make an arrow, so we'll just write it on the other side of the board. I have to make sure I'm dividing it by 9, okay, on both sides. And the reason we do that is so this 9 just cancels out. All right, everyone sees that? And this is going to be the value for a. And a is equal to 1. Okay, I'm going to box my answer here. Also if you're doing the value for a here, remember it doesn't have to be a whole number. Okay, it can also be a fraction. In this case, it is a whole number. If it's a fraction, make sure you're just reducing your answer, okay, when you put it in the equation. So I'm going to put, therefore, let's use f of x, okay? So f of x equals, okay, the value for a, which is 1. Okay, and then I'm just using my vertex, okay? The vertex point was -3, so I'm putting plus 3 squared. Okay, and the y point of the vertex is -4, so I'm going to put -4. Okay, just like this. Alright, so again, if you notice, whenever the value is 1, I actually don't need to put that in my final answer. Okay, you can put f of x. I can even just put y equals, okay? A lot of teachers want to see f of x because it is a function. I'm just going to put x plus 3 squared minus 4. Okay, so just like this. And I can see this is already in the vertex form. Okay, if the teacher says to change it back into the standard form, I can just expand my answer here. Okay, and this vertex form can easily be changed back into the standard form of the equation. Okay, so here it's basically given as a graph, but again, it could just be written in words like this is the vertex of the quadratic function and this point lies on the quadratic function. And I would basically use the same method to calculate the value of a, and I'm always looking for the value of a. Okay, in this case, because the value of a is 1, okay, this is neither a stretch or a compression. Okay, it's basically the equation of the quadratic function where the value of a is 1. It's neither a stretch nor a compression. Okay, so the quadratic function, if you were to graph it out, it's not going to be like wider or more narrow. It's just going to be how the regular function looks. Okay, and remember the parent function for the quadratic is the y equals x squared. Okay, so just like this. So that looks good. Okay, and that brings this video to an end. We covered math 11 and the topic was basically the vertex form of the quadratic function. I hope everyone enjoyed this content. And again, if you did, please make sure you're subscribing to the channel and click on the like button below. And I will see everyone next time. Thanks. Bye.